Hi, welcome to another video in my baseline series where I'm baselining the normal operation of my BMW 116i E87. Now my one has some differences because it's a 116 trophy racing car, but most of the stuff that I present here is standard because the engine on the 116 trophy is pretty much standard. Okay, so what I'd encourage you to do is go to my website, pauloffordracing.com, and you'll find here under this baseline menu, you'll find entries for all the different baseline exercises that I've undertaken. And then you can drop into those and you can get a bit more information in those sections. In this video we're going to look at the crankshaft sensor and the camshaft sensors. So the crankshaft sensor sits adjacent to the toothed wheel that you see here in this diagram, and I'm not quite sure how many teeth there are on this ring on the crankshaft. It looks as though there's perhaps one every 3 degrees, about 120, but I'm not, don't quote me on that. But importantly, there is a tooth that is missing, and so that creates a unique pattern at a point in the rotation of the crank. I don't know whether that is at top dead center or bottom dead center, or if it's just at some other degree, some other degree of rotation. But that's how the engine knows the relative position of the crank. There are two sensors for the camshaft, one for inlet and one for exhaust, and they are bolted onto the end of the camshaft with the bolt that actually holds the Vanos camshaft timing adjusters. So the sensors here are those numbered 14, and the Vanos adjuster, the two adjusters, you can see one there is labelled number 5. Importantly, the sensors show the position of the camshaft. Remember that the relative to the timing chain position, it will change as the Vanos units operate. The sensors sit on the edge of the timing rings, those parts number 14, and so you can see that it will produce some quite unique patterns because of the segments that are sort of cut away, they're in a particular pattern, and that will create a particular pattern of signal on the sensors. On both the crank and the cam sensors, when metal passes close to the sensor, the signal goes down, and then as the gaps appear, the signal goes back up. So you can think of it as an inverted pulse. Okay, so I'm going to try and measure the signals for ignition coil number 1, which I'll be using as the trigger for my oscilloscope, the two cam sensors, inlet and exhaust, and the crank sensor. Now the cam sensors and the crank sensor are all connected to module 3 on the ECU. So what I've done is I've removed the shroud around module 3 so that I can back probe the connector. Not ideal, but I felt that was the best way to go. The trouble is, I could try to use insulation piercing probes, but for example, the signals for the two cam sensors are both black wires, and I don't know which one's which. So, and if I see that coming out of the back of the shroud, I won't know which one's which. And there's other coloured, green is a popular colour. So I haven't got multiple greens here actually. I've got one green, which is the crankshaft sensor, and then I've got the one ignition coil. The ignition coils are connected on module 5, which is the one at the far end. We'll look at the circuit diagram in a minute, but I just thought I'd show you how I've arranged the sort of connections in back probing the ECU connectors. So here we see the crank sensor wiring into the DME, which is the grey box in the centre of the page. You can see I actually probed the green wire on pin 27. A word, I'm sure you know this if you use an oscilloscope, but don't connect up multiple grounds on your oscilloscope, just use one. And what I did was I connected channel 1 ground to the main ground for the ECU. Don't connect any others, because there's some dangers if there's any if they're not actual grounds and they're floating voltages and things. So yeah, just make sure you do that. Okay, so that was that one, and then you can see the cam sensor for the inlet cam on the right hand side, and I probed pin 29 on the DME, which is the black wire. The other cam sensor, the exhaust one, is again connected with a black wire on pin 30, so I probed that one. On the ignition coil, I probed the switch ground on the low voltage side, you know, the yeah, not the high voltage. Well, you can't really probe that anyway, but I think you can with a current probe or something. But anyway, so I did it appears here in black and white. That's not the colour scheme on my car. So on my car it was just a white wire. I think it might have had a little black spot on it. Looked at it as though it had been painted on. But I'm sure you may have seen my other videos on measuring the ignition coils. It's a switch ground set up on the low voltage side of the ignition coil, or the primary side, if you like, of the ignition coil. Okay, let's start the car and run it. What I'm going to do is I'm going to let it tick over. It has been running already, so I think it should be warmed up enough not to have to go on to open loop operation, so it should be on closed loop. And assuming that's true, then what I'm going to do is I'm going to rev the car to see what effect we get on the see if we can see the Vanos working, and also variations in spark timing. Although I have to say I'm a bit worried about me not being out here to adjust the time base on the scope, so we might not achieve that, but we'll see what we get anyway. Let's just check the signals. It's interesting, the channel 4 is AC coupled. Yeah, why is that such, it's not very square shape, is it? Okay, so that's one of the cam sensors. Yeah, I think that's the exhaust sensor. I mean, the shapes are there, but I don't understand why we've got this sloping effect, because if you look on the other sensor we haven't. Let me just see if I can adjust I switched it off now. Just rescale it. Okay, I don't know why that's doing that. Let's go back to look at channel 3, which is the inlet. Let's move that. Let's move it down. Okay, there isn't a slope on the top of that channel, is there? Okay, I mean it's got clean edges, so it should be okay. Now what you can see here is you can see the notch out of the crank sensor, the crank ring, you know, all those teeth, and I'm triggering it on this one here, which is the spark plug ignition coil number 1. So I'm triggering on ignition coil number 1. You can see that is happening relative to this. I'm not quite sure where the marker is on this. I don't think it could be bottom dead center, I suppose, on bottom dead center for cylinder number 1. That might make sense, but I mean, it could be some sort of arbitrary position, I'm not sure. And then we've got obviously we've got the sensors for the inlet valve cam here, and the sensor on the end of the exhaust cam. Okay, so let me try. I'll tell you what I'll do. Let's increase the time-based speed a bit. Not like that. Like that. That gives us a bit more detail. The triggering is being a bit funny because, well, I don't know. There isn't really a reason, I suppose. It's just you get some variation all the time in what's going on. Anyway, let me rev it and we'll see if we get any variation in these timings. Actually, before I do that, let's save this. Okay. Okay, we'll stop there so I don't annoy the neighbours anymore, and we'll review the video. This is running the video at 1/10 speed. All the signals will get squished because of the increased engine speed, but what you want to do is look at the relationship between the edges of the blue signal and the pink signal. The blue signal has moved back relative to the purple signal. If we look at these 2 points here, you can see that the blue edge has moved slightly behind pink edge. And if we go back to the original waveform before I revved the car, you can see that here the blue waveform is well ahead of the pink. So what does that actually mean? Well, I think it means that the exhaust is closing later, and maybe the inlet is closing a bit earlier, so the inlet has moved further forward and the exhaust has moved back a little, but we'll need to check the inlet to see if we can see if there's been a change there. Because the signals get sort of compressed as the engine speed goes up, we need to choose an edge that's very close to the trigger point. So the red arrow there is showing where, and the small t shows you where the trigger point is. And if we look at this edge just here, that is just about in line. So that's our best reference, I think, for checking to see if there is any movement in the inlet timing. Another point worth noting when we look at the yellow trace and you look at the that's the signal for the ignition coil, you can see the multi-spark effect, and as we'll see as the engine speed goes up, that drops away and it doesn't use multi-spark. So this is at idle. Let's look at it when it's at the peak RPM. So here we have the engine running at about 4,800 RPM, and you can see the reference point at the top, and we can see the edge that we were interested in on the pink trace. Now, eyeballing it, I think it has moved slightly to the left, which means that that's the pink edge. That means the valve timing has become slightly advanced, but it's not very clear, I have to say. So let's see if we can add something else that'll give us a bit more information. Okay, here we're looking at OBD scanner output. Sorry about the smash screen, but I think you can see the values. So you can see the engine speed is increasing, and we've not got any movement of the exhaust valve relative to the inlet on the scope trace until we get to there, so that's 1381. And you're already seeing movement. Now, one thing that concerns me is overrun, but we'll talk about that in a second. Let's keep watching this for the moment. I think you'll see at 3200, you'll see the blue trace moves a long way to the right relative to the pink trace. So where we 2400, here we go. We're going up, so that's 3185. Well, it's dropped away again, 18. So it's dropped away to 1800. This is where I think I was having trouble holding constant speed, because it's really difficult when the car isn't under load. Actually, this is a problem we have when we noise test these cars. They say, "I'll rev it to 4,500 and hold it," and it's really difficult because they've got a lightweight flywheel. There's no sort of, resistance there to work against. But you can clearly see there at 3269. The exhaust timing has moved a heck of a lot, and the numbers, the Vanos position numbers, exhaust and inlet, they move. I'll let you watch this again at your own leisure, sort of scroll backwards and forwards through it, but I can tell you what I see, and that is that I was expecting the Vanos for the inlet and exhaust, maybe at different times, but I was expecting them to switch on at a certain RPM and that would be it. That isn't what you seem to see. So I don't know if they manipulate the values to flatten out the torque curve, if they, I don't think it's variable, is it? It's a solenoid, so that actuates it. So the solenoid opens, the oil flows into the cam adjuster, and it just moves. I don't think there's any variability in it, but there could be. They may actuate the inlet and exhaust solenoids at different times, at different RPMs, and I do wonder if overrun and the engine not being under load is having an effect here, because if you think about it, the cam adjusters on the end of the camshafts are quite heavy, and so they're going to get some inertia, and when you take your foot off the accelerator, that's going to pull on the chain tensioner, the timing chain tensioner, and the cam timing will change, and that will be picked up by the cam timing sensors. So maybe that's also confusing things here. I think in terms of what we were trying to achieve in this, the main thing I wanted to look at was, what do normal cam signals look like and the crank signals, and I think we can see that. Whether we can work further and actually see if the Vanos, the units are working correctly, I don't know. So far, not with what I've done or with the tools available to me. But I hope you found that interesting. I certainly found I've learned a lot. It's confused me a lot. So there are some things I still don't understand, but we can see the results of the Vanos units working.